This is the last part of Unit 1. It mainly focuses on periodic trends. And what you see here is if we classify the elements, there is some variation in the periodic table with regards to the molar atomic volume versus the atomic number. And you can see that at the beginning of every period where you have say potassium, rubidium and cesium, those are the elements that have the largest volume, and as you go across the periods, the size of the element changes, as you well know. So this is mostly a revision section where if you have a look at the periodic table, the modern day periodic table classifies the elements into the alkaline earth metals, which we have over here. Group 1 are classified as the alkaline metals, Group 2 is alkaline earth metals. Groups 3 to 11 are the transition elements. And then we've got group 13 to 17. The yellow boxes are classified as representative elements. Group 16 or 6, whichever you prefer, are classified as what's called chalcogens. Then group 17 or group 7, as you may know it from school, are the halogens, and then group 18 or group 8, as you may know it, are the noble gases. And then of course we have the lanthanoids, which insert into period 6, and the actinoids, which insert in between the S and D blocks of period 7. Okay, another representation of the modern day periodic table is just give you some idea of the different ways it can be written. Of course, if we have a look at atomic radii, we know that as we go across a period, the atomic radius decreases, and if we go down a group, the atomic radius increases. Okay, this is straight from first year chemistry. This includes the atomic and ionic radii. If we look at another way that we can represent this on a graph, you can see that if we start at group 1 and we go across the period, then we have a decrease in atomic and ionic radius. And another table just to show you the actual values in picometers. If we look at ionization energy, go and revise the periodic trend in ionization energy. The tables will help you to do that, as will the graph that's on the right hand side of this particular slide. We can have a look at the same thing for electron affinity. Go and revise that from your first year work, because it will be tested on, or assessed on rather. Okay, electronegativities. This is quite an important characteristic for periodic trends. And the Pauling electronegativity is mostly used, and you can see that the values increase going across the periods. Okay, also we talk about polarizability. What is this? This is where we have small highly charged cations have high polarizing ability, and large highly charged anions are easily polarized. So what you can see here, if we look at the diagram, you will see that we have a very strong positive charge over here, and the negative charge starts to be polarized. So in other words, it's pulled in this direction towards the positives. Okay, so cations that don't have noble gas configurations are very easily polarized, especially from the D block elements onwards.